Alright, this is the video for rate of change basic. Okay, so one key fact is that the average velocity is the average rate of change, is the change in h over the change in t. Alright, you might have seen this as this change in h over change in t. You might have seen this as change in s over change in t. In functions basic, you might have seen this as change in f over change in t. So whenever you have a function, h of t, s of t, f of t, the average rate of change is any of these. Okay, when the function gives you the position of a moving object, then it's also the average velocity. You'll see that in problem 1. On this assignment, that it gives you a position function. Let's see, the position function they give you is h of t. This is the height. Height is a position, right? Your height is a position. So this is a position function, h of t. Meters there, that's the units, okay? This is a position function, so the change in h over the change in t, this is the average rate of change, also the average velocity. All right, so to do problem 1, where they want you to compute the average velocity over the time interval 0.5, 2.5, what you're going to do is compute let's see, you've got h of so you compute this number. Okay, put 2.5 in there for t, that'll be that number, minus putting 0.5 in there. Okay, the thing to remember, let's see, you've got 35 times 2.5 minus 4.9, 2.5 squared, is that negative goes to both terms. 35, 0.5 minus 4.9. Okay, you compute you do all this math. Remember the order of operations and all that. Put the answer in. Remember, this is going to be since this is meters and time is in seconds, right? So since this is in meters and this is in seconds, your answer is going to be meters over seconds. But for whatever reason, we often think of it as meters per second. Okay, those will be your units. Problem 2. T minus t squared. All right, so there's a number of things for you to do here. There's 7 boxes to fill in. let me try and recreate that a little bit here. There's a little box down here. Okay, so what they want in each of these boxes, and there's more down here. Yes, there is. There's more intervals listed here. Let's see, what is that? 1.9 and 2, and here is 1.99 and 2, 1.999 and 2. Okay, and you got to put stuff here, 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 and then figure out the instantaneous velocity. All right, so we don't know the instantaneous velocity. We're still kind of in the process of defining that in this class. This last box here, instantaneous velocity. Okay, but this exercise, the point of this exercise is to get at how we're going to define the instantaneous velocity. All right, we're looking for the instantaneous velocity at 2. All right, so what we're going to do is we're going to use the average velocity, otherwise known as the average rate of change, that which you computed a lot in functions basic and functions advanced. So we're going to use that average rate of change to define the instantaneous rate of change. All right, so for each of these boxes, what do we do? Okay, so I'll show you that now. All right, I'll just show you what we're going to do here, and then I'll talk about, I'll show you how to compute this one here, and then I'll just tell you what these are, and I'll talk about the big picture so that you can get the instantaneous velocity. All right. Okay, so to get this one here, right, to get the answer that goes into that little box there and what is sign, I'm computing the change in h over the change in t for this interval. That's h of 2.1 minus h of 2. 2.1 minus 2. And if you do all of that math, putting the 2.1 in for t there, computing that number, and subtracting, putting a 2 in for that number, let's see, we get 12.910 meters per second. Okay, so something like that. Okay. All right, so I'm going to erase all this, and I'm going to organize this in a table. I think the table will make it a little more clear what we're trying to do. Interval. Okay, now remember we just computed, okay, right, we just computed this right here. Right, and we got 12.910 meters per second. Okay, if we do exactly the same thing, computing the change in h over the change in t for each of these intervals, except for this one, I'm going to talk about that in just a second, we get all of these numbers. 13.395 Okay, now if we were to try and compute this interval here, right? Let's look at that real fast. Okay, so change in h over change in t over the interval 2, 2. Now let's see what we get. All right, so you have h of 2 minus h of 2 all over 2 minus 2. Okay, h of 2 minus itself, that's 0. 2 minus 2 is 0, okay? So this is undefined or meaningless. Okay, so we're trying to find, so the instantaneous rate of change, that's the rate of change at exactly 2. You can think of it as we're shrinking the interval down to a point, to a singular point at 2. But that's undefined. It's meaningless to us. It means nothing to us, all right? Because 0 over 0 is a meaningless expression. So what we're going to do, the instantaneous rate of change, is the number that we approach as we make each of these intervals smaller. And notice that this interval is smaller than that one, this interval is smaller than that one, smaller than that one, and same thing. This interval is smaller than that one, this interval is smaller than that one. So we're narrowing in, getting closer to 2, 2. Okay, so as we narrow in on 2, as we approach 2, we think about what number are we narrowing in on? Let's see. You can see that we're getting closer to 13.4 this way, and here we're getting closer to 13.4 this way. So we're narrowing in on 13.4. This is our instantaneous velocity. Don't forget the units, meters per second. Now this is the instantaneous velocity at t equals 2.